video. This time around we are talking about volume of a conical frustum. There's a question before us and I would like us we do it in two methods, and I would really advise that you be looking out for the second method. So please just be patient up to the end of the video. It is quite an interesting method to learn. So volume of a conical frustum, there is a question before us. Find the volume of the frustum. So what I'm going to advance is the common method. And I'm going to call it method 1. So given such a question, usually we say it's good that you try to imagine how the original cone was looking like by simply extending the lines. If you extend them, it will give you a clue on how the original cone was looking like, and maybe from there now we can be able to tackle that question very well. So before the cone was cut right there, so that now we have the frustum. It was originally a very big cone, and if we complete like that, now we can see two similar cones. We have a smaller one, then the big one. The next thing we want to do is to know the formula we are going to use so that we see if we have all the items we need to be able to do this question successfully. So the formula for finding volume of a frustum, a conical frustum, is usually given by a third pi r squared h. In this case, we are using capital R and capital H to show that it is the big cone, minus a third pi r squared h. Again, now here we are using the smaller letters to show that it refers to the volume of the cone that was cut off, the small one. If we can subtract the two, then it will give us the volume of the frustum. Now, what we are missing from the formula, or what we have in the formula that we do not have in the diagram, is the two values of h, the big H and the small h. So what we need is to be able to sketch out this right angle triangle and use similarities for us to be able to find the solution. So I'm going to sketch it out for us so that we can use it. So I want to put in the information that we have. So here it is, remember it is the perpendicular height. So here we are told it is 4 centimeters. Here we are given as 2 centimeters. And then that height there is 12. What we don't have is this small height. If we can get it, we can as well get the bigger height by simply adding h plus 12. So the knowledge of similarities, we get the ratio of similar sides. We can say the height of the smaller cone divided by the height of the larger cone should be equivalent to the smaller radius over the larger radius. So if I do that cross multiplication, I'm going to have 4h being equal to 2h plus 24. Now from here I can collect like terms, and 2h coming this side, of course it will give me 4h minus 2, which will be 2h being equal to 24. Dividing through, you have h as 12. If h, the smaller one, is 12, the bigger one, we know it is now this 12 plus 12, which will be 24. And just like that, similarities has helped us to get the two values of h that we need for us to use the formula. Next now is to put in the information in the formula given. So a third, let me use 22 over 7 as pi. You can use the calculator pi. So 22 over 7 times 4 squared multiplied by 24. Now I'm going to subtract a third multiplied by pi again. Now 2 squared times 12. If I feed this in the calculator, it will give me a value. The first part, it will give me 402.29. For the second part, I will have 50.29. Subtracting the two, it comes to 352 centimeters cubed. So that is the first method, how you can be able to find volume. On to the second method. So allow me to bring in the same frustum. Maybe I can try to make it a bit larger. Now, the second formula is quite easy. You don't need to complete it, or neither do you need to use similarities, especially if you are given the height of the frustum and also the two values of radius. So I'm going to write down the formula down first. Volume will be given by a third pi h into r squared plus r plus r squared. If you have some knowledge in binomial expansion, then this one should be very easy for you to remember. Now, this value of h that we are using here is not the height of the cone, but rather it is the height of the frustum. Like in this case, now it is 12. So putting in the values in the formula, I'll have a third. Again, I'm going to use 22/7 as pi multiplied by 12 into 4 square plus 4 times 2 plus 2 squared. Again, if you use your calculator well, it will give you 352 centimeters cubed. So this second method is a bit straightforward and it works very well, especially if you have the height of the of the frustum, and you also have the radius on the top side and on the lower side. But if you are, let's say, given the slant height from here to here, you cannot use this formula straight away. You need to use similarities first to at least know the height of that particular frustum. Otherwise, that's it for now. Look forward for the next video and remember to subscribe.